right. All right. So an ellipse is the set of all points x and y, the sum of whose distances from two fixed points, both sides constant. That should be a small a if you want it to be consistent with everything else. Small a is the distance from the center to a vertex on the major axis. That should be a small b. B is the distance from the center to the co-vertex. So the ones on the longer are going to be the two vertices. The ones on the small are going to be co-vertices. That's how we're going to distinguish between them. And c is the distance from a center to a focus. Now the standard form of an equation. A couple things to keep in mind as you look at this. Number one, all right, this is always a plus sign, always. So it's a plus sign between them. If not, then it's not an ellipse. It's hyperbola, which we'll do beginning Wednesday. Number two, this is always equal to what? 1. That's where our fraction is going to come from. So instead of figuring out what the radius is, that's going to be 1. And then we're going to figure out the individual lengths through the denominators. The foci lie on the major axis, c units from the center. All right, and this is the last major point. C squared equals a squared minus b squared. A squared and b squared are your denominators. So all you're going to do is subtract your denominators and do a square root to find c, the distance from the focus to the center. The focus lies on the major axis. Boom, we got it all covered. So let's look at some graphs, shall we? All right. What's that? I don't think it says, but I think it's in your best interest. All right. So I'm looking at an equation. Number 1, is my right-hand side of the equation equal to 1? Yes. Number 2, is there a plus sign between them? Is everything squared? Yes. All right. So what's the opposite of positive 3? Negative 3. All right, negative 3. What's the opposite of negative 2? 2. Everybody okay with that? Yeah. Okay, now what's bigger, 16 or 9? Not 16. Not 9, 16. Got me? So that means the x, the horizontal, is your major axis. So when I plot it, center negative 3, 2 is no different than what we've been doing. Center negative 3, 2 is no different than what we've been doing. But the vertices are going to be the square root of 16 away. What is the square root of 16? 4. So we're going to go 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. And those are our vertices. All right, so our vertices are at 1, 2, and negative 7, 2. So again, unlike the parabola that had 1 vertex, the ellipse has 2, and they're on the major axis. Now, good? I just counted 4 across. And because the 16 was on the x, x is horizontal. That's all you got to do. All right? Now I look at the other part of my equation, which is the vertical part. I look at its denominator, which is 9. What is the square root of 9? 3. So that means I'm going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. That comes from the smaller of the two numbers. No, those are the co-vertices. The foci, okay, are going to come from the major axis. We'll go through it in a second. All right? So everybody good with that? The vertices, the center, and what we call the co-vertices. All right, we then connect it to create our oval. So that's our ellipse. Now, to get your foci, you put a square root symbol, and you add your denominators. What's 16 plus 9?
25.
25. You will notice, all right, you will notice, oh, not 25, sorry. We're subtracting. 7. I know, I've ruined your whole day. We're subtracting. So 16 minus 9 is 7. Now, when it is not a perfect square, like in this case, all you're going to do for the foci is start with the x-coordinate of the center, which is negative 3, put a plus minus, and then the square root of 7. And then the y coordinate of the foci stays the same. So it's negative 3 plus minus square root of 7 over 2. What?
Square root of 7 over 2?
No, just negative 3 plus minus square root of 7 comma 2, because there's 2 of them. All right, the negative 3 plus minus root 7 is involves 2 points, one with the plus, one with the minus. All right. I will double check the quiz tonight to see if you actually physically have to graph them. I don't believe you do, but that's it. We're not going to do a lot with the foci because it really doesn't affect the graph much. All right. Everybody good thus far? All right. Now the second one. The second one. All right. 2 things that are different. Number 1, where's the bigger denominator now? The x or the y, the y. So that means our major axis is going to be the vertical. Make sense? Everybody good? Okay. What's the opposite of negative 4? 4. What do we assume the y coordinate is? 0. So 4, 0 is our center. Good? So the center has nothing to do with what's bigger. I then look at my bigger denominator, which is 25. I do the square root of 25. What is the square root of 25? 5. So I go up 5. 1, 2, 3, 4, 5. And down 5. 1, 2, 3, 4, 5. Those are my vertices. So my vertices are at 4, 5, or negative 5. My co-vertices are then created by the smaller number. What is the square root of 4? 2. So I go 2 right and 2 left. And I have my ellipse, but this time it's a vertical ellipse. Good? All right, then to get our foci, I put my square root symbol, and I subtract. What's 25 minus 4? 21. The x-coordinate now stays the same, so that's 4. And then you can write plus minus square root of 21. If you want to write the 0, feel free.
Oh, why is it 4 comma?
Because it's a coordinate point. They're coordinate points.
Like, why is it not?
Because you're adding it to the y, not the x. That's why I just said you can write the 0 point. So see how this is 0, Jeff?
Yeah.
It's 0. Technically, it's 0 plus minus 21. It's your choice if you want to write the 0 or not. Because it's on the same as the major axis. So in other words, when you look at this, either in your head or on paper, this is what should be going on. What's bigger, 25 or 4? 25 is bigger than 4. So that means the y is the major and x is the minor. All right? And then the foci are always on the major axis. So it always goes with the y. Make sense?
Yeah.
All right. Okay, so after you get through the first 2 in this assignment, you will find some that are not in standard form, which means we're going to be completing the square. So I got 9x squared plus 4y squared plus 36x minus 24y plus 36 equals 0. I'm going to take my 9x squared. What am I going to move alongside it? 36x. Awesome. I'm then going to write my 4y squared. What am I going to write alongside that? Negative 24y. Good? Equals what type of 36 over there on the right-hand side? Negative. All right? Does 9 go into 36? Yes, that's fortunate, but it doesn't matter. We're going to pull it out no matter what. X squared plus 4x. We're then going to cut the 4 in half. What is half of 4? 2 and 2 squared. 4. So I'm completing the square. Plus, what is the coefficient of y squared? 4y squared minus 6y. Half of 6 is 3. 3 squared is. Everybody good at this point? All right. Now on the other side, what did I start with? Negative 36. And this is very important. I added 4, yes, but there's a 9 on the outside. So technically I didn't add 4. I added 4 times what? 9, which is 36 plus 36. And I did the same thing with the y's. It doesn't always have to be the same number. In this case, it was. All right, does everybody understand where the 236's come from before moving on? All right, now I'm going to finish completing the square here. 9 times x plus 2 squared plus 4 times y minus 3 squared equals, these cancel out, regular 36. All right, what is the denominator? What is this always equal to in an ellipse? So you got to divide by whatever that number is. Can 9 over 36 be reduced? 1/4. So that becomes x plus 2 squared over 4. 4 over 36 reduces down to 1 over 9. Y minus 3 squared over 9 equals 1. Is it now in the format I want? Yes. My center is the opposite of positive 2, better known as negative 2, and the opposite of negative 3, which is 3. What's bigger, 4 or 9? 9 makes my y-axis the major axis, so my vertices are negative 2, 0, and negative 2, 6. Everybody good with that? Okay. Then my foci, what am I going to do with 9 and 4? Subtract. And that gives me the square root of 5. All right. And then that would become, the foci would be negative 2, comma, 3 plus minus square root of 5. Good? Yes, ma'am. I reduced the fraction, so 9 over 36 is 1/4. So really this is 1/4. And then I just moved the 4 on the bottom. Because I want this to be what on the right-hand side? 1. So for everybody, all I do is divide both sides by whatever that number is. No matter what. We want that to be 1. Okay.
Do the vertices again. Or
Do the what again?
the
The vertices?
yeah.
The vertices?
The vert dot dot. The vert dot dot.
Okay. So to get the vertices, I take the bigger of the two denominators, which is 9. I do the square root of that. What is the square root of 9? All right. And then I take that and I add it and subtract it to my center. Because the y is the major axis, that tells me I do it to the y coordinate. 3 plus 3 is what gave me the 6. 3 minus 3 is what gave me the 0. Good? And then
Why is that in the y-axis?
because it's always on the major axis.
Why is the 3 plus?
Because, okay, so here's my center, negative 2, 3. Go back to that. All right, and then my vertices are negative 2, 0, and negative 2, 6. My curved vertices will be the square root of 4, which is 2. All right, so I'm just going to sketch it really quick. You're asking me why, which is a good question. The foci are always on the major axis. You got me? So this is the major axis. It's the longer axis. All right, so that tells me I add it to the y. Whatever the major axis is, that's what you add to. Good? All right, so to finish up for today, why don't you work on that one, please? 9x squared plus 4y squared minus 54x plus 40y plus 37 equals 0. Anybody's looking for extra help, you can find me in the 910 library today. If anybody's looking to make something up, I will also be there. Just let me know so I know to brief you. What?
Not today.
I didn't say today. What is your lunch period? Absolutely.
Alright,
Lally, no problem. And did I respond quietly enough that you didn't feel like you were being yelled at? Okay, just making sure. Because I want you to feel comfortable in my class. That's very important.
I got a very, really big number. Is that wrong?
I haven't worked it. You're getting a very big number for what? The right-hand side?
Kind of. Because like I have to do 9 times 9 is 81. Then I have to do 25 times 4 is 100.
Right. You could get a big number. Because you remember you got to do a square root of it to get your axis. God bless.
So the
Oh, because why?
Why?
Oh, I never done it. It's like off the graph.
It's a little bit off the graph on the bottom, which is okay. What? Okay, so you just gotta figure out a day to take that quiz. We'll talk at the end of class. Talk at the end of class.
I don't know how to do this. How do you find the, so it's one. It's 36 minus 16. Oh,
I'm not missing the last number.
You cut that in half and then square it. So what's 86? 3 squared is 9. Have 10, 5 plus 3.
Excuse the interruption. Can I have Tyler Purvis, please, 1112?
Absolutely.
Thank you.
You're welcome. Good luck.
If there's a 1 here, there's a 1 down there, or
If there's a 1 with what?
no? Like, never mind, it's fine.
Did you get a center of 3, negative 5?
Yeah.
All right. Did you get vertices of 3, 1 and 3, negative 11? Okay, so we got that covered. We're good? Because that covers the completing the squared part. Now, is everybody good that 36 minus 16 is 20? The one thing you got to do is you do have to simplify your radical. So the square root of 20 is 2 root 5 when you do the foci. All right. Now, once again, where was my major axis? Y. So I'm going to add that to the y coordinate of my center. So that makes my foci at 3. And then you just put negative 5. What symbol follows it? Plus or minus 2 root 5.
Like, say I didn't do the 2 root 5 part.
Like if you just had root 20, you lose like half a point. You know what I mean? So if that one's worth like 5, you get 4 points. It's not a huge, like, but it's still something you should do. But you're good with getting it to 20?
Yeah.
And you're good with where it should be, the X and Y?
Yeah, I don't know how to do that.
Then you're fine. All right. Any other last second questions? Anybody at home got any questions about this? Hold on one sec. We're going to go through the homework to make sure we understand. All right, so those of you at home, it is in the Google classwork section. For those of you in the building, you should be, this all is due, by the way, tomorrow at midnight, all of it together. It's one assignment in Google Classroom. All right, so it's due tomorrow at midnight. 1 through 12 all involves graphing. You should be able to do all 12 tonight. All right, and it says, identify the vertices and foci of each. You do not have to graph the foci, you just have to write them down. All right, and then sketch the graph, so then you sketch it. Give me half a second. I just want to go over one thing. When you complete the square, ladies and gentlemen, so here's a freebie, number 7. Okay, for number 7, when there is no x, when there is no y, you do not have to complete the square with that part. That makes sense? Because there's no x and y part. So if we walk through the beginning of it, we would get the negative 180 on the other side, right? So that would give us 4x squared plus 9y squared equals positive 180. Now, real quick, you divide by 180. If you ever want to know what that is, you can just do 180 divided by 4 and put that in your denominator. I heard some of you talking about that in the back. So in other words, you can just do that divided by that and put in the bottom if that's easier for you. So like 180 divided by 4 would be 45. And then 180 divided by 9 would be 20. Okay? So x squared plus y squared. All right. Now, here's the thing. When you do your center is going to be what? Since there's no number being added or subtracted, 0, 0. Good. All right. Your vertices, what's bigger, 45 or 20? 45. So now you're back on the x-axis. So it's plus minus the square root of what? 45, which should be 3 root 5. And then 0. And then your foci, all right, we would subtract what's 45 and minus 20. What's 45 minus 20? 25. Which is a what? Perfect square. What's the square root of 25? So now your foci are 5, 0 and negative 5, 0. So when they're perfect squares, you got to write them separately.
Is that like the other way around? The vert is like
The both
too low.
sides is the whole of the square
Hold on. To get A and B, you just do the square root of that. Get your foci, you subtract. What's 45 minus 20? 25. Your foci come from the difference. Your vertices come from just the numbers themselves.
How come the vertex has been the double pointer every other time?
Has been the what?
It's like the one with 2 points.
That does have, okay. Now I got you. The plus minus means it's 2 points. So that's positive, that's 3 root 50 and negative 3 root 50. That makes sense? So they've kind of just switched roles. The plus minus always means 2 points. How's that? Good?
Why don't I figure that one too? It's the same thing, it's plus minus.
Because 25 is a what? Perfect square. And what's the square root of 25? So that's the only time you're responsible for writing them separately. So this is the same thing as plus minus square root of 25. You just now have to write them separately. Okay? So keep that in mind as you do it, because you notice, like, for example, in number 10, all right, is there a y part in number 10? No. So for the y's, do you have to complete the square? No. All right?
Yes, sir.
Good? What? Yeah. Yeah. You just have to graph them. When, like, you can estimate these. So, like, for the vertices, the 3 root 5, you can that's like 6.6. So you can just estimate it to the 10th when you graph it. All right. If you're good, if you have no more questions, I have no more answers. Those of you at home, have a great day. If you need help, virtual math lab is available today. Just check the math lab Google Classroom. Be safe, everybody.
Can I just see the rest of this? May I go to the bathroom?
We'll have so many questions at once. Yes, Lally, you can go to the bathroom.